The Edifice Complex podcast is brought to you by DCM, the Drawing Specialists, Blue Rhythm Commissioning Software, and Sensor Suite, the future of intelligent buildings.
Welcome to the Edifice Complex, the property design and development podcast. Let your hosts Adam Muggleton and Robert Bean keep you up with who is innovating and doing great work, perspective on the adjacent possible, and challenges to the status quo.
Welcome to the Edifice Complex. I'm Robert Bean, your co-host and unofficial mediator, here with my colleague, official agitator, friend, and Yoda of most anything to do with buildings, Mr. Adam Muggleton. Say hello, Sir Yoda.
Hello there. I'm good to see you laughing because I'm also a lunatic and we were just talking about that. So there you go.
Lunatics are good. Lunatics are good. Today's guest is Director of Commissioning and Energy Services for U.S. West at Stantec, a name everybody recognizes. He's a graduate of Arizona State University with 2 master's degrees, one in architecture and the other one in the science of the built environment, and continues to teach at ASU on commissioning. Welcome to the show, Marcus Myers.
Hi, nice to have you. Go Devils.
Marcus, you have one foot in architecture and another foot in engineering. That makes you both dangerous, interesting, and useful.
Triple threat.
Triple threat. Tell our listeners how you ended up identifying with architecture and engineering. How'd you get to where you are today?
Well, interesting enough, I'm one of those guys that, I started out as, my dad was a military guy. And so it was always like hands-on, always be hands-on. And I don't know, I've been working in construction. It starts well before that in construction. Since I've been 14, those landscaping jobs you do in the summer, and then you start working stuff. You get your first belt, with your tool belts, and so you're proud of it. And I still have it, actually, the first one. So, hands-on is very important to actually just get involved, listen to people, find the right mentors, ask a lot of questions, and then just start building. And before you know it, it was just me and my mom, because my dad passed when I was in high school. And so, I didn't have a dad anymore. So I became the man of the house, and I had to fix stuff, fixing things, right? And so it's just, believe it or not, I actually think I still have those books. Oh, this is great, right? One of my first books I ever got, and this is a trip right here, is Home Depot 1, 2, 3. Right? And it's funny, I haven't looked at that book in probably 20 years, but and books are important too. You can learn from a lot. So it just became one thing over another, is learning stuff, learning this, how to do a footer, how to do this, how to do a deck, how to do a roof, how to do that, how to do electrical. And then it just slowly shot into that. And it was interesting because there's a lot in between there, but it's just like my first 2 degrees were like marketing and finance, right? Who would have thought, and then I came back, and then I just got, it was funny because my mom, I'm a Sun Devil. My mom's a Sun Devil. My dad's a Sun Devil. My brother's a Sun Devil. So, ASU it's in my blood, maroon gold. So there's an epiphany story here, right? So one day I was sitting in the back in my mom's house in upstate New York, and I built a deck. And then basically, we were talking about, what am I going to do with my life? You know what I mean? After I, graduated for the first time from ASU, and then she's like, you've always been happy. She goes, she called it, you whistle while you work. Right. And so she goes, you love to build things. So I literally, it was truthfully. So I went upstairs, I got on, back then it was like what, you got mail. I can't remember what it was, like dial up. Right. And I went online and I looked ASU and I looked at engineering. And I came back to school, believe it or not, for structural engineering. And then when I got here, I ended up taking a lot of mechanical engineering courses, and I went 3 years with mechanical. And then one day I met an architect. It's really funny, Scott Hayward. He used to be the curator at the at the Tempe Historical Museum. Awesome guy. I haven't talked to him since then, but if he sees this, love you, Scott, for helping me out. And he basically talked about a lot of different areas and how you can take structural, you can take architecture and engineering, and you can just do a lot with it. So I went down, And I basically applied for both schools. I think I was the second one at ASU to apply for both architecture and engineering. And then I went through it, and literally for the next like 3 years, I don't know where I parked my car because I couldn't sleep. And let me tell you, it's hard to do high math when you're tired. But interesting enough, fast forward with all that, and when I got done in 2008 with some degrees, we hit the recession. We were in a recession. Okay. Remember the Great Recession? Oh, yeah. And there were no jobs. Okay. I don't think a lot of people understand there were no jobs. I literally applied to like probably 100 different firms and said, I will work for free. I need experience, right? I mean, experience in the architectural world, the engineering world, outside of construction. Because when I got to Arizona, when I came back to school, I mean, I've been in construction, like I said. So it's just like, I started a small little construction firm. I wasn't licensed, so I couldn't call it construction. So handyman, right? So, and believe it or not, my clients were the professors at ASU. I marketed myself to the professors, and I started fixing all their houses. I must have fixed 40 different professors, and I was making money while I was going to school. And it just, I'm talking like solar systems, hot water systems, didn't matter systems. Yeah. You know what I mean? And there's a point to this, because everyone asked me how I got into this. Well, when you're a little older and you come back to school at like, 26 and you're trying to get out of school and you're like 30, right? And you're like, oh no. And then you realize that there are no jobs. What am I doing? I just went. So that's when I said energy. I had this little moment right there, and I said, I will never not be employable again. At that moment, I said, energy. Okay. Energy, right? So I was that architectural guy, engineering guy that focused on building envelope. I focused on control systems. Like I didn't really know what it was then, but I was an energy modeler. I mean, I focused on modeling, with the BIPSA, International Building Performance Simulation Association, right? And I learned in modeling. So basically modeling, to me is basically everything. It's the virtual world of commissioning. You can't touch it, right? But you can virtually be part of everything, part loads, chillers, and you can get into it, and you can get, and then we had Marlon Addison, the creator of eQuest, basically has been my mentor since then. Dr. Harvey Bryant, one of the, most notable, sustainable fellows in ASHRAE and FAIA, Dr. Edmundo Sotero, the university architect. Dr. Agami Reddy. Dr. Slotsky. We're talking about ASU. The list goes on and on and on. And these gentlemen took me under their wing, and they showed me everything. So it's just like, so when recession, we make old better. When it's going upward, we make new great. So it became this, I was never going to not have a job. That was the most important thing. When people don't understand, when you're young, yeah, and you're like, I need to make money, I need to get a job. It's usually out of pure desperation that like something happens.
Totally. It's survival mode, man. You're at the bottom of Maslow's hierarchy. You got to eat.
I did. Yeah, exactly. It was survival of the fittest, and I went back a little older. So remember, like when you go back after you've graduated, you don't get these good loans. You don't get the Pell Grants. You get jacked up with 6 or 7%, for basically student loans. And people don't realize, when you go back the second time, you really try and you get good grades, and you're that person going, you know what I mean? And because so that was it. That's really what happened. And before you know it, working for ASU, I was a research assistant for a bunch of different folks. For Brian, and basically also for Dr. Avi Vizel. A few other people. There was a lot of folks that basically really helped me out, and they gave me the RA positions, TA positions. And then basically as a researcher, I just loved it. And they were paying me. Think about it. When you get paid to do what you love, it's not work. So it just sort of transcended into that. And that's how it all happened. And believe it or not, this is going to sound crazy, but one of my first real opportunities was, over at another company, right? And they gave me an opportunity to go in there, and I basically became this person that dealt with ASU. And so I jumped in and basically started doing it. When I first was like, wait, commissioning, I was like, I'm being paid to make sure someone else did their job. It was a trip.
Mic drop, we're done.
Exactly. It was so confusing to me. And then I started realizing just how complex the entire process is, because there are, all the addendums, all the RFIs, all the ASIs, all the different trades, the 400,000 pieces, like the 1,000 people, all the different parts. And then basically, the best thing that we ever did was BIM. And the worst thing we ever did was BIM, because now
BIM bam.
Because remember, before we did the drawings, I wasn't back in the day with Vellum, but we remember layering, basically, so we can actually see what's going on with what system's going here and here and here. And then BIM was like, boom, they're like, I want a door there. I want this. I want the beam moved there. And then just like addendum. And it didn't realize that everything has to move for everything else. Then everything has to be coordinated, and all the trades have to get coordinated. There's so many moving parts. And so then it was just like quality assurance, basically QA, QC. That word commissioning really means a process of improvement. And I struggle with this every day, even to now, when we talk about what is commissioning, what do we do? It's like a Superman world, you know what I mean? And a Superman word, sorry, or woman, you know what I mean? It's one of those things where you don't know exactly what it is. And you keep on learning what it does. And then before you know it, you have to keep learning and reading books. And then you have to understand the synergy between basically MEP and controls and envelope, roof, walls, windows, all the different pieces. Because I love those worlds. And every day I don't stop. I keep on taking classes on controls. I keep on taking classes on thermography. For instance, think about it, like a kid with Legos, like Fleur. We're looking at infrared camera. We just bought one of these, basically, a new one. We've had a few of them, but this is like a brand, C95. It's not the brand new one, but it's awesome. That's like my Legos. Are you kidding me? I love this stuff. So whenever I lecture, whenever I go to presentations, people are like, I'm like, you want coffee? You drinking coffee? I'm like, no, man, this is just fun. So
there's a few things to unpack there for our listeners. So one, that camera looks like my dad's 1970s Super Cine 8, Super 8 camera.
Yeah.
So nostalgia, Chris Bump. But there's a few things to unpack there. Like one, you can have a sunk cost of like several years and hundreds of thousands of dollars. And your first life lesson is no one knows you anything, including a job. So you need to understand that, right? Pick your degree wisely. Thing number two is it's on you to hustle and get that job, right?
Absolutely.
And you got to make yourself useful. You got to add value. No one owes you a job. You got to get out there and add some value, right? And find your niche. There's nothing wrong with bouncing around. Just be valuable while you do it, right? So, that's interesting because that origin story is unique and typical at the same time, right? It's typical in that you got to hustle, you got to grind your way through the work. You can't half-ass an engineering degrry, right? Let's be honest. You got to wake up at some point and do the work, and then
but you also got to figure out what you're doing, why you're doing it. That's the one thing that a lot of people don't do. They say, "Here's your toolbox. What do I do it with?" A lot of these engineers, listen, they come out of school and they don't even know what a chiller is. That's what I'm always trying to basically. I wish there was laboratories. I wish there was practicums. Practical. All I emphasize is, and ASU is really a good school for practicality. It's a good practicality school, right? It's just that, but I think there would be more hands-on. I want more laboratories, more touch it, more play with, more break it. You know what I mean? Wow, what can we do?
I want to put a pin in that and come back to that later with your work with the teaching commissioning, because one of my big issues with engineering degrees is I used to be an employer. You interview a graduate and they're great at math and they can do calculus. That's great, but they are completely useless to me. They don't know what a pump, a chiller, or a fan is. They can't size anything. It is a complete waste. I have to spend 2 years fixing them before they're useful. And there's a lack of applied teaching at universities, in my opinion.
Well, and the next part, let's think about it. So not only basically how to do the right engineering, basically, start with the end in mind. Basically, you don't know what a good design is because you know what a bad design is. That's one. And then two is basically sales. How do you sell your, how do you brand yourself? How do you brand your company? How do you sell it? From the moment that someone starts, working with me, is I basically show them where the money is, how it works, because then they take ownership, they have accountability, and then they don't just bill to a job. I want people who take it personal. When you work for a friend, they're not my client, it's a friend. You know what I mean? It's like a trusted friend. It's my family. I mean, I treat every building that I work on, not just for ASU, any building I work on, I treat it like basically it's my house. And you know what I mean? And then in working for Stantec, I act like I own the company because I've owned companies. So it's accountability. We all have to walk, because people don't hire your company. They hire you that work for a company. And when you embrace the pillars of what that company is about, I mean, that's like you don't work for a company, you work with people, and you have that company with you. And I love Stantec, truthfully, because the people are amazing. I mean, Tim Howe that I work with, Jerry Pickett, Kishore Warrior, Greg Schwarm, the list goes on. Just amazing human beings that make my day better. And I mean, I could literally list like off probably 80 people or 1,000 people, because I talk to so many. I talk a lot, right? But yeah, it's just great, and thank you both, by the way. This is awesome. Adam, I've known you for years now through LinkedIn, and just met this wonderful gentleman below today, but we have some good stories already. So thank you all very much for doing this.
Yeah, no, it's great to have you on. I mean, what are we? We're a few minutes in, and there's already a bunch of high points here. One of the things that is, obviously leaping through the communication here is your ability to express the passion that you have for what you're doing. You said something that was really good. We're going to talk about this again in our wind up, and that is whistle while you work. I love that.
That's my mom.
That is so wise. If you think about and it's an unconscious thing, right? I mean, you just catch yourself whistling while you work, or singing or whatever it is. Clearly your body is responding to positive, whatever's going on in your world at that moment. It's positive.
Brain to body, right? Boom.
Brain to body link. And so that is huge. And when Adam and I do our wind up at the end of the show, Adam, we're going to talk about that, because that is really powerful. But one of the other things that's coming out of this interview is, you can have all the knowledge in the world that you like, and there's a lot of people that have a lot of brain power, but if you can't communicate in a way that invokes action, that knowledge is, well, you're basically a walking library, but that's about it. Yeah. People can't get in and they can't come out with anything, right? Because you don't have the ability to communicate. So communication is huge, and you do a great job of it.
And confidence, though, this is another thing I try to instill in my students, and it's what a lot of my good mentors have, is to help you understand your value. Because once you understand your value, and one of my very good friends who just passed this recent year, Greg Kuntz, I love that man. He was a mentor for me. He was a vice president over at Siemens for a while, and he was one of the best people in the world when it came to Excel. That guy was an Excel guru, right? And I'll never forget, one engineer, 30 years, the guy was amazing. And one time we were starting a project, and he basically just started doing a bin, of basically numbers, and we're just going down from 45 all the way to 90. I'm like, what are you doing? He goes, I'm just creating my my bin for my temperatures. And I'm like, well, what's a rule of thumb? He goes, Marcus, after 30 years of doing this, he goes, my rules of thumb, he goes, are pretty much factual. He goes, so it's the value that I bring as an engineer of 30 years that understands this. He goes, so there's not really a go-to, do this. It's you have to basically understand it through experiences of what temperatures, what gradients, why you're going to do it, how you're going to get to it. And it starts to make you think, one day you hopefully will be an expert, and one day people will listen to you. But at the same time, when I teach the students, I always basically say, I never just give them my way. I basically say, especially with Google and, and all the stuff that you can do, we never had it. I had a good library, right? But now you have the world and the universe in front of you. And I would say, go out and find the right template, pick one. Which one? Pick one. Which one looks good to you? And so I do this on purpose, because I want the students to basically look what they think is right and why. And so write a paper on why they thought. And then we come into class, we compare these, right? I don't like when people tell you, use this, unless it's best practices and standards, because then it's an industry, but they have to understand what is good and what is bad. Remember the old comment? You don't know how good jasmine smells until you basically know how bad it smells. So
Yeah, that's it's another good point. When I go back and I think about all the teaching I did, and one of the biggest challenges that we had was with adult learners was when they had no experience, right? That they were very apprehensive to take a guess, to try stuff. And so I think it was probably 2-3 years into teaching that I realized, okay, the problem isn't that they don't know, they're not afraid to do the sequence, they just don't know where to start. And so I would put on a great big piece of paper or on a screen or whatever, the word try.
Yeah.
Try, Try. And I said, there is no right and no wrong, except the only wrong thing they can do is if you don't try. So try something, just get going. And then that first step will then help you navigate the rest of the way through the calculation. And just do it. Just explore.
Also, too, is like in college, one of the points I emphasize is like I'm in the classes and I'm teaching. And I go, hey, this is the place to fail. You can fail in this class, and then I don't mean get an F. I mean basically fail because I want you to try and fail. Fail.
Exactly.
The real workforce, they hire you based on your resume that says I can do this. Yeah. And so, it's just like when I mentor people here, I go, hey, listen, you know what? Call me anytime you want after 5 o'clock, but I can't pay you to do homework.
Yeah.
You know what I mean? Because basically they expect you to know how to do it, right? But when you're in college, get A's, whatever like that, but learn, try and fail. That's the place to do it in the classroom is when you're not in industry, because there we can help it. But that's what happens. We need to basically say to someone, it is okay to fail. It is okay to be wrong. It is okay to learn. Remember, like the little thing that says, aim small, miss small, and one more thing, I'll just jump to it. And people always ask me, they go, well, what is your definition of failure or success? I go, okay, so I succeeded today. So that means that I failed that much less today than I did yesterday. But today I win. I go, I never stopped trying to be successful. It's just basically on any given Sunday, you're always trying to be it. But for some reason today, I'm a winner, but basically I just won by that much. Always take the chance and the risk to fail, but understand when you get in industry and, your decisions are very important, you have to always weigh everything you do very consciously. So, but you have to learn how to be confident. You have to learn how, and that's what mentors are for. And I think mentorships have gone not where they need to go in the last 50 years and literally like it's like being a dad or a mom. I'm not one, you know what I mean? But it's just at the same time, it's my students I want them to be more successful than I ever was. I don't want to ever keep them down. I don't want them to write papers for me. I want them to be the best they can be. And Sir, Richard Branson, basically, I think it was him that always says is train them so well they can lead and treat them so well they'll stay.
Yeah.
So sorry, man, go.
Yeah, we've said this before in the show. There was a professor, Mark Baumberg, who's a really interesting guy, and he would say, you can't sit down at the computer unless you already know the answers. And I always took that to heart. And I remember, and again, for those that listen to the show on a regular basis, sometimes we're going to repeat our stories here, but, we would hire engineers or graduates out of the engineering programs, and all of their colleagues or fellow students would end up with jobs, and right away they'd end up on the software. Like the other companies would be teaching them how to use the software, but not us. They weren't allowed to touch the computers until they did hand calculations. I think it was 6 to 9 months, sometimes longer for some of them. And the reason is because we wanted them to get a feel for the numbers.
Yes.
Right. And to develop that self-intuition, those internal checks and balances where you say, okay, we started on this path, we started to try these numbers, and we're starting to approach the boundaries, conditions, and, are we actually on the right path? And then and getting them to develop that internal sense of direction of what can you be confident in your numbers, that you're willing to stand on them, and then finally stamp those drawings. And our people always ended up much better engineers than anybody else.
It's also understanding what them constants are in certain calculations, right? It's not 4.2 or whatever. It's something, right? What is it?
Yeah.
You know what I mean?
Well, and then that's one of the other things is that when people are new to the world of engineering, and they actually, any profession where there's numbers that are involved or science that's involved, is they don't have a sense of what is precision and what is accuracy, and when do you need one or both. And you can have somebody, let's just take for example marksmanship, right? You can have a perfect pattern of 6 shots on a target, but they're off the target. So you're precisely wrong.
Yeah.
Right. Yeah. Or you can have 6 shots that circle the center, but maybe they're not all on the center, but they're accurate. Right. And so when we get into numbers, for example, they don't know how many decimal places you need to carry into a calculation. Right. And we would just say, listen, you only need to be as accurate as the instrumentation that you use in the field. So if you're using an analog device like a pressure gauge, well, pressure gauge isn't going to tell you the difference between 14.5 and 14.2319. So forget it. Like, you don't need to be that precise. But developing that sense of precision and accuracy, and when you need to be both, and when actually one can be misleading, is really important.
That's applied engineering versus pure engineering, almost, right?
Right.
Pure calculations.
100% too is always, obviously thermodynamics, it's just, or psychometric charts or controls. It's, you got to help show someone the relationships between things, right? Because it's always, God is in the details. It's always right here. But the most important thing that I always try to do is I'm an analogy kind of guy, right? It's just like, I always basically, because they're like, you can never, you're saying something, they're like, it's like deer in the headlights, and you're like, I get it. You're not connecting it. So you always have to try to find something. Like, look in your house, look in your apartment. The first thing with architects, I'm like I go, what do I draw? I'm like, look to your left. Where are you sitting? Oh, I'm sitting right here. Look at your ducts. Are you feeling cold? Are you feeling hot? Connect it to something personal. And then they start to go, that's what that is. I'm like, a load calc, like a heat gain. Heat's coming in. Heat's going through. Yes. And what? And then then like the bells go off, and then it's just like, that's what it is. And isn't it kind of funny? Then someone's like, because they already know everything you've been saying, but you got to find that connection point with each student, and nobody learns the same. Nobody. And that's why this whole standardized thing is wrong. It's just basically every, either, reading, watching, viewing, taking them out to the site. Some people are just, they look at it and they photographic memory. Other people, they have to see it, you have to touch it. But I think we need to take the time to find out what it is that really connects what you're trying to do with that person. And then that person, they pay it forward. You know what I mean? Like, and they go, they took the time for me. I'm going to take the time for you. And that's what I think sometimes lacking a little bit in engineering and architecture is you still have those amazing mentors, but some people are like, come on, it's quicker. And you're like, what? And then so they do it quick. And then of course, then someone's got to go back and redline it and check it. And it's just like efficiency, effectiveness. I mean, it really starts with basically understanding that person and working with them. And once you do that, you create someone just like you. And then they became caring and empathetic, and then they take the time, and then they realize that deep breath, don't rush through it. And that's how we create leaders.
So there's a couple of things I want to unpack that you said earlier, right? And just now. So one is for any junior engineers or undergraduates listening, going to site and seeing and visualizing and touching what we're talking about and what you're studying is really important.
Yep.
If you keep it in the abstract, you're never going to understand it, right? So make someone take you to site and explain things to you. That's the difference. But the other thing I really want to emphasize as well, if you've done a 4-year engineering degree, you come out, I'm a degree and my mum loves me and she's so proud, then you think you're not a salesman or person, right? You are, right? It comes down to even being able to sell your concept. If you're designing a DOAS system and no one wants it, you got to sell that sucker to the team, right? So anyone listening to this, trust me, you're a salesperson all your career.
Yep.
Selling your ideas, yourself, your brand, your knowledge, hopefully your work, your business, right? But just down to that micro level, selling your idea, your design, your concept, you got to be able to do that, or you're not going to get anywhere, right? So you touched on a really important thing there. Two things I think are takeaways. Applied engineering is as important as the fundamentals, and you all are and all will be salespeople, no matter what profession you do.
Yeah, and also KISS. Remember, keep it simple, stupid.
Keep it simple.
Okay, I mean, like literally, like do not make a sequence overcomplicated. I mean, you got.
Don't get me going on that.
Yeah, that's another thing. We'll talk about that more later. But it's just like it calls for this. It says this. We need this. Okay, just start simple, high level. You can. Engineering is only as complicated as you make it.
Yeah,
you know what
totally.
I mean?
I was just got interviewed by Joe Hughes and Cliff Zolnick on IQ Radio, and if you haven't listened to it, Marcus, you should. It's a great show, and Adam and I got a thing going on here soon. I'm really looking forward to that show, by the way. Anyways, they had asked me about HVAC systems and technology and complications, and I said, "See this gray hair?" Said, yeah. I'm actually only 22. It's the technology that's created it. All of us, anybody that's been around the industry a long time, we've been up the technology ladder and down again. And I've not come across one individual that has embraced high technology as a solution. Everybody I know that has any experience says, nope, simple.
We still look to the psychrometric chart that Mr. Carrier created. How many almost 100 years ago? And we still apply everything. Thermodynamics is still hot to cold, high pressure to low pressure. Water runs downhill. Okay, so you know what? Einstein is still correct. You know what I mean? The laws of thermodynamics and energy are still solid. So
it's not complicated, right? People overcomplicate everything.
They do.
Yeah.
I want to just have a quick talk about your director of commissioning at Stantec. So Stantec is a pretty gargantuan firm, and I know commissioning is a sort of like subset of the services that they do there. But what's going on? What's the state of play with commissioning at Stantec? Because Stantec's an important firm.
Yeah, I mean, it's an amazing firm. I mean, I believe we're I think the number one AE firm in the country this year, based on the other ones. Right. And then commissioning has been here at Stantec for about 28, 30 years. We have a lot of different offices throughout Canada and the United States, and we're growing it. And they brought me on basically to enhance and grow it. And in all reality, all I'm really doing is internally marketing. I mean, all I'm doing is basically getting all the engineers and architects and folks in the country to basically just come together and basically say, we already do this anyways. We work together. So it's just like, externally selling, we already have every client in the universe, right? All I have to do is basically it's true. I mean, it's just amazing. They do so much. I mean, so many sectors. Oh my God. It's just so much fun here. I get a jump between infrastructure, ports, marines, government work. I mean, mining. I mean, power and dams. I mean, every single day. I mean, literally today, I've already had 4 calls with different sector groups, and we're bringing this together, and we're talking about integration, collaboration, cross-selling, cross-marketing. And I mean, all I'm doing is basically just, bringing more and more. And Stantec, we're coming hard. Okay. Commissioning world, you know what I mean? So it's just like, we're growing fast, and we're going to do it good because we got a lot of good people that care. And all you do is basically just bring it together and say, what services can we also offer the client and our trusted friends, to basically bring out. And then we're really just trying to bring all that together. And once again, it's just like a lot of other companies, you know what I mean? That they amazing structure, amazing folks, big firms. And remember one thing, okay? Always remember one thing. I work, I'm in the firm called Stantec, but as commissioning, we are a disinterested third party. I am not on the construction team. I am not on the design. We don't have construction. I'm not on the design team. I am not on the architectural team. I am a disinterested third party. Okay. And we can, and other firms do commission the work that team works on. So there is no, fox watching the hen house. That has been basically passed by lead, passed by everybody. Basically, it's agreed on, right? And now with lead, with the addendum that came out in February 2021, that basically says you can be in the same firm and you can do all these things. Because everybody thinks, oh, you can't do that. That is not true. And I am one of the most ethical and moral people. And that's why I sit on the BCA and basically 9 other TCs for all these other things. I will always do the right way. And there will always be no conflict of interest. And whoever hired by the owner advocate, we always will do the right thing. And everybody on my team will do that. And we do that. So
yeah, people need to understand just how important that statement was, because if you break that contract, because that's a moral and an ethical contract that you're making. It is a social contract. Yes. And so if you break that even once, you're tainted for life. And so I'm glad to hear you say that, because
well, and another thing, just to let you know, I mean, one of the areas that I've been pushing for years is for this, and basically, it's now changed. And maybe I bark a little loud, but I believe what I bark, right? The next one is, hopefully in the next, I'm not going to say in my lifetime, hopefully in the next few years, just like you got basically, you got a board, of registration that basically monitors architecture, that basically monitors engineering, where basically my goal and hopes are that we can all work together. So there is actually accountability for commissioning, because right now it's just, we have a national certification through ANSI, AHRI, BCA, ASHRAE, AEE, there's a few of them, right? That, that make you do continuous education. That's why they're basically, approved for the DOE and everything else. But like, there needs to be accountability, because owners like, well, what do I do if this didn't work out? Where do I go? They don't. Oh, just don't hire them again? No. And that's the thing that separates, people who are certified and basically people who aren't, or maybe so. And then basically, not to say that smaller firms or bigger firms, it doesn't matter. It's basically the work that you do should be a best practice at all times. And every one of us should be hitting the highest marks possible to make sure that we are delivering the highest quality assurance, meeting the OPR, Guideline 0. And by the way, every one of my students who can acclaim to this, I make them memorize Guideline 0 definition of commissioning. That is part of their classwork. Like every day. Who wants to stand up? Just the other day, I did 7 people. They stood up. And when the students grade them, I go, did they hit it? Because they're all watching going, you put installed before this. Do it again. I ask them. I made them do one person the other day 8 times over. They're like, and I'm like, will you forget it? No. That's the thing about it is. And I gave a quiz on psychrometrics the other night. And one of my last questions was, what does psychrometrics mean? And I go, you just took a quiz. You just studied for an entire week, but you didn't know what it means. You know what I mean? So that's the kind of thing about it is it's like, we have to ingrain what we do and why we do it and how we do it. And basically, and then they have to teach others the exact same thing. But got to have standards, got to have best practices. BC.
Well, and you brought, again, the difference between, you didn't use the word, but qualified versus certified. Yeah. Easy to get certifications, not so easy to be qualified, right? And you can have people who are qualified and uncertified, and you can have people who are certified that are unqualified, right?
Yes. And a lot of people say, oh, I don't have the acronyms. I didn't take the certification. I'm like, that's great. You shouldn't, according to the DOE, you have to have, hey, you know what? You don't have to go to college, but basically if they require you to basically have a stamp, then you have to. You can't go, I can design stuff all day long. Not according to the law. Yeah. Like, you have to abide by the rules and jump through the hoops. I'm sorry. There are hoops out there you have to jump through, and you have to do it. Sorry, everybody. But
there's nobody on the other end of the line that's going to go, oh, you'll be fine. Yeah. We're going to coddle you and make you feel good about your, your attitude. The attitude you need is one, like, suck it up. You have to go through you have to get your hands dirty. You got to put your mind through some shit that you may not like. Yeah. But when you get out the other side, you'll be able to look back and go, okay, did it, can do it again.
No matter what people want to say, we still live in basically a competitive world. You know what I mean?
Yep.
It's just like, I don't want to use those words like capitalism or socialism, but listen, everything is basically, you're competing. You're always trying to do, and remember, you don't want to claw over someone, but at the same time, remember, not everybody gets a trophy for, playing good. It's just like you get ahead because you are better. You work harder. You push through strife, through basically trials and tribulation. I always called it baptized by fire. How many times have we went into a building and we don't know what the hell that thing is, but you stayed up the entire night to basically read up on it. You read all the specs, you read this, you walk in the next day going, I get it. You know what I mean? And it's just like, but they're paying you, and they're paying you good money.
Yeah.
Right. So you better bring that value, and you better go do your homework. And if not, you better call somebody.
Yeah.
You got to get it done. There is no like, I have a deadline. I was tired. Get it done.
There's two stories there. And that is that it behooves us as professionals that when someone is on the other side about to take that first step to come through to our side, that there are going to be anxious. There are people that will be anxious. There will be people that that might have some fear and that kind of stuff, and that we need to be careful in guiding them through with respect and empathy. Yeah. But rest assured, for those that are listening, we will guide those who take that step with anxiousness and maybe fear and whatever. But for the love of God, be prepared. You don't get to the other side and have a breakdown because someone gives you shit because they're calling you on the map because you weren't prepared. And that's happened to us before in meetings where, some young engineer, graduate student came into our meetings, left in tears. And the reason for it is that they came into the room unprepared. Yep. And what pissed us off is that, and this is for those that maybe aren't familiar, we're at an ASHRAE meeting. You might have 30 people around a table or 40 people around a table. All of those people there have left their jobs to volunteer work. The hourly value at that table is in the tens of thousands. Yep. You need to respect the value at that table. And when you come into a meeting and you're unprepared and you're trying to get something out of that committee and you're not prepared, expect a tongue lashing.
Yeah, sorry doesn't cut it. Like basically,
sorry does not cut it.
If you're on time, you're late. Hello.
Yeah.
You know what I mean? Like all the coaches we ever had, if you're on time, you're late. Think about that. It's just like you should be early. And if you are going to be late, you call before you're late and say, you know what I mean? So it's just like, there's just accountability that, that I don't know. I'm trying to help out, but sometimes I feel like I'm so harsh these days in this politically correct world. And I'm trying to do my best, but it's just like, how do you emphasize that? Sorry, no second chance.
If you join the Navy SEALs, we can't be coddling people. If you join the Navy SEALs, it's not personal. It's can you run for 2 miles with a boat on your head? Yes or no, right?
Yeah.
It's not, I like you, I don't like you, you've got a nice haircut. It's, can you do it, yes or no? If no, it's not for you. Right?
Well, and another thing too is, here's the thing. It's like, so like, let's say with me, like, with Stantec, I'm literally knocking on everybody's door saying, hey, can we do this? Can we do that? Can we collaborate? And then so they're like, oh, well, yeah. And all of a sudden they go, hey, here's an opportunity. And so it's like Thursday and it's like due Friday. So I'm over here begging, right, over the last couple of years. And then basically they give it. And I'm like, I'll get it done tonight. I'll stay up all night and I'll get it done. And then basically then it starts, because I'm not going to basically say, hey, give me a chance. You know what I mean? And then all of a sudden they give it to me. I'm going to do it. And then the chances keep on increasing. And hopefully maybe I'll have like 3 days to do it, 4 days. But you know how it is in this world where, with RFPs and RFQs and jobs that come out, it's just like, and most people don't really think about how can I be part of this because they listen to you give presentation until they go, I have a project that I'm working on that right now. And they're like, but you're like, wait, I just presented to you 4 times before this. They go, but I need it right now. So I'm always trying to figure out how we actually can reach people. Remember, this is just industry. You're always basically trying to connect. You're trying to connect with people.
Yeah.
So when they hear something, it's a trigger word. And it's automatically, that's the person I want to go to. Or do you know the person that needs to go to? I mean, that's what we need to be doing. We need to be basically pushing it to the right people to help out, all of us. Collaborate, advocate, don't compete, don't be that person. There's so much work out there. Yeah. Just advocate and collaborate and be happy for other people when they win work.
The Edifice Complex will continue in just a moment.
Can you find the drawing and supporting documents you need in less than a minute? Now you can with Echo. It's simple. Just type what you're looking for and press enter. Echo knows your building. Speak with a drawing specialist today. Ask about our special offer of painless onboarding plus 6 months free with Echo. Visit podcast.thedsoffer.com. That's podcast.thedsoffer.com.
And now, back to the show.
Now, I want to talk about two things. I want to hit on your work teaching commissioning at Arizona State University. Then I want to talk about your article in Consultant Specifying Engineer in this month. Yeah. So let's start with Arizona State University. You got the hat? I presume you got the tattoo somewhere.
I got the
hat. So there are vanishingly few commissioning courses, particularly at university level. So how did you pull that off?
Truth be known, it's funny. I actually wrote when I was a grad student years ago, I actually thought about this, and I basically I said, if we had a high performance building certificate, what would it have? And I always believed that it should have 2 commissioning courses, right? 2 energy management, or basically energy modeling classes, basically. And then I always 2 controls classes. So it was always 2 commissioning, energy modeling, or it could be energy management, but energy modeling is very important. And then basically control. So then it's combine those. So I always thought that in order to have a certificate or, something that people want to do is, you have this brief, you have this. So about, 3-4 years ago, I was trying again. And then basically there, a new chair of the School of Construction, Dr. Tony LaManna, he's just an awesome human being. I love this guy. And he's like, this is a great idea. He's like, and I go, well, I presented to another school and another school at ASU, and they're like, but Tony is just so forward thinking. And he's just good with people. He's a construction guy. You know what I mean? Yeah. He's from Louisiana. You know what I mean? He likes beer. He likes to talk, and he's just cool. Right. And maybe it doesn't fit in academics, but he's awesome. Right. And so we thought this idea and we took it, we ran with it. We started the class. We did another one. We got a line item and took 2 years to get a permanent number. We went to another one. And then now I can't stop the students from taking it. Everybody just, now they want to teach more and more and more. And I'm just like, because, when they come in the class, it's like, all right, sit down, listen, we're going to teach you. It's old school. You know what I mean? I don't.
Right on.
Boom, and construction engineers, construction managers, architects, engineers, and I'm trying to get now in the future. It takes a while with academics. You got to go through the proper channels, and you got to prove that it's an elective for a core, it's an elective for this. I mean, it just takes time. I get it, right? And it's been an amazing process. But I mean, Dr. Christian Paris, Dr. Pat Phelan, Dr. Tony LaManna, I mean, it's just good people, that really want the benefit, and then they work with you, and then they start saying, let's do it more, and then that's why ASU is amazing, and Dr. Crow is awesome, and that's why we're the best.
So, and you teach 2 classes, right? You teach
I teach 2 classes a semester, introduction and advanced. And it's going to be more, actually. Well, I can't teach all the classes. I'm trying to get more people to come in and do different. We're trying to create this high performing building certificate. That's next. It just takes time. But yeah. And remember, intro, I'm sure these kids are going to tell you if you ever ask them, it's not intro. You know what I mean? And advanced, I like to jump in more of the envelope stuff, more in the controls. I like to jump more into MEP systems, just basically talking about outside air, supply air, return air, mixing air. I like to go into more of like the practicality kind of stuff, the practicum of it. But it takes a little while to understand it.
Yeah. Again, very applied, right? You've got to have the basic fundamental knowledge there to understand that.
Well, and now, that COVID's loosening up and basically, we can get back out to sites. That's an important part, but it was hard for that year without it, and teaching on, it's just, we're all getting better at it, but you gotta show, like I said, analogy, you gotta show them, you gotta find what writes for them. And, but it's like I said, you got to bring passion, and every day for those 2.5 hours that I have them there, I mean, I bring it, you know what I mean? And it's just like, but
it's like a Tony Robbins thing.
No, man, I bring it, and it's just like, and I'm like, hey, I got you for 2.5 hours. I'm like, you pay me respect, I'll give you respect. Let's work. You know what I mean? And it probably drive them crazy, but they learn. That's all that matters, is they learn. And when they leave here, they learn and they don't forget. And I make them keep their binders and their notes, like when we always have, like, it's over here, but it's just like, you always keep your CEM notes. You always keep your other notes. You always, all the engineering notes, all the architecture notes, I have thousands of notebooks.
Yeah. So how big is the student body? How many people are you putting through the machine every year?
It was increasing from 15 to 25 to 40 to 45. And now my classes are all at I'd say 45 per, class.
That's good. That's nice.
Those are big classes.
It's a lot.
Yeah.
Truthfully, and I want to teach more in more of a bigger lecture hall, because they keep on giving me bigger rooms, but sometimes it's hard to really have that intimate, thought process when they're all just out there, and it's just, and it's great, but I don't want to slim down the material, you know what I mean? Because I want to, and that's why maybe it's going to be an intro, then advanced, and then maybe the next semester it'll be, part 3 and part 4. It's just so hard to try to get it all in there, because, commissioning is not just go flip a switch. It's everything, and you have to learn so much. And
so it's interesting. There's that class size growing. There's some point where it crosses a line between class and showbiz. Do you know what I mean? At some point, you've got enough people in front of you, you feel like a juggling monkey, not a teacher. Do you know?
Yeah, and all the students, they want to learn, and it's just sometimes it's just remember those 400 person lecture halls. And I mean, who knows if you fell asleep? You know what I mean? But at the same time,
sitting in the back
exactly. But it's just like I said, is they're always trying to find a right balance. And I wish all I care about is every student actually has a full impact of what we're trying to do and embrace it. That's all.
Okay, that's awesome, man. We'll put something in the show notes about so people can find information on it. But I do want to also talk about. So on top of being like a superhero at night, fighting crime, running Stantec's commissioning department, teaching, you also found time to write an article with some colleagues.
Oh, yeah.
In the Consultant Specified Engineer, the CSE magazine, October 2021 issue. And the article was titled, Deliver Smart Buildings Using CSI Division 25 Commissioning. So for our international audience, before we get into this, can you explain CSI Division 25, what it is?
Yeah, integrated automation. Basically, whenever all the different specs, 22, 23, 26, mechanical, plumbing, electrical type of things, they always talk about the individual pieces, but there's 25 has been around for a few years, okay? And the thing is, it's getting more and more popular because now you're starting to really connect all the pieces. In all honesty, it's a spec, okay? And basically, it just defines out what you do when it comes to controls and how the different pieces are layered. And you have a lot of different companies out there that have been trying this for years to, hey, how can I put HVAC and lighting together? How can I do this and this? Because before we used to just have, it was HVAC, it was lighting, it was this. We had different pieces. And now we're starting to try to figure out how they all connect. Integrated automation, right? So you're integrating all these pieces. So so with that right there, integrated automation, let's look at smart building, which is integrated automation. Whenever you're like, clap on, you know what I mean? Clap off, right? So you want this, you want the lights to perform with this, but you want the walls to perform with that. You want basically an occupancy counter. You wanted to work with the daylight and harvesting. You want Because remember, what is the point of a smart building? The point of a smart building is that it reacts and it thinks based on algorithms. It's not AI yet, right? Artificial intelligence, but it's going to react based on, okay, this many people came in, this came in, we're going to shift the loads, we're going to do this. It's basically taking all the existing systems we have and basically putting them into a brain. And like a FDD, fault diagnostic detection, you know what I mean? So it's like, basically, it's like you're going to preventative maintenance. It's like like analytics, like let's say SkySpark. I love that name, SkySpark. It's like there's sparks before fire, sparks before fire, right? So basically, you're always trying to figure out how these are working with this, how this side, how diversity is, how North is working with this, how you walk into this, how this, and eventually, the skin and the system, the mechanical system, one day they already do in some amazing buildings. One day it's going to work together, and it's going to basically be able to say, oh, we know that you're not comfortable because you're having a draft. We're going to correct that before you have to go, I'm cold. We're going to basically, they know the building's going to work together. That's what it really is. It's basically it's a spec that defines, one, what people do at certain stages, what subcontractors, controls contractors, what the different pieces. It's almost like a performance specs in a lot of ways, right? So you're defining what happens with what, when it goes here, how it does here, who does what. It makes it better for owners. It does take a little while to develop, right? But at the same time, as long as you make it broad, because what is a spec? A spec is basically like a written scope of work, but it gives a parameter. It gives a range. That's all it is. There's no means and methods. You never tell someone exactly what to do. You're giving them basically a range of things of how to do it, how it should perform, and basically, what is the tolerances? It's like basically putting in a tile and someone's like, that's got an inch gap, that's got a quarter gap. You're like, well, it should be a quarter gap.
Right? But do you find, I've always found historically, particularly in North America, there's a reluctance for design engineers to write control specs?
Honestly, it's just like, not going to say what's right or what's wrong, what they should do. But I mean,
loaded question. I don't know. Sorry.
It is, but if it's like at the same time, if it's an engineer sequence of operations, in the past, it was always basically a controlled matrix, DI, digital in, digital out, AI, analog in. One is basically a range and one is on and off. And all the pieces of equipment, just like BACnet, standard 135, it basically labels it out. So it's BACnet over Modbus, Ethernet, TCP, IP, MSTP, right? Basically what it is you have all these different network architectures and all these different, areas and supervisories and pieces. And it's just like, how do they really work with each other? And how, in all honesty, you're trying to pretty much get less operator, each day to fix it. You're basically trying, that's what control systems are. Remember, like in the past, it was one lever arm. Yeah. And then it basically turned into 5 lever arms that controlled 4. And then it was basically one that controlled 50. Well, controls are nothing but little fingers that are automated that controls things that when this happens, I mean, that's what people understand. It's just little fingers, little lever arms, and that's all we're trying to get to. Exactly. Before they used to say, oh, it's hot, it's cold, it's hot, it's cold. Now you have, remember you have P, proportional, then you have integrated, then you have, derivative, and now we have a PI or PID, or PI. So the loops,
fuzzy,
how they learn,
fuzzy
how they
logic.
recruit.
Don't forget fuzzy logic.
Fuzzy logic. I mean, there's so many. I mean, listen, this is the world of Internet of Things, IoT. It's here. Sorry if you don't know, it is. Literally, you can live and order everything off Amazon. Okay. IoT is here to stay. Everything here is AI is growing. And, commissioning will always exist because there's always human error. It's not the control's fault. It's the programmer's fault, right? It doesn't go, oh, I did that. No, it still has human error. So as long as the world is being built by humans and we err, to err is human, right? We make mistakes, but controls are about programming. And basically integrated automation and Division 25 is a wonderful spec to have and to really bring out what you need to do, because it could be so vast. It could be 70 pages, it could be 5 pages, it could be 3 pages. I mean, whatever you need to do for your client, and that's what matters, is what are their expectations and needs. And don't try to force something down someone's throat. What they need at that moment and how they can grow with it. And it is a living document.
the reason I liked your article was I always talk about a building as a system of systems, right? It's a facade system. It's AI, it's CCTV, and commissioning to some degree is interface management. The soft and hard interfaces between these systems. That's how I describe it when I talk to groups about it. And that's what I liked about what you're writing about here. Division 25, a lot of people don't even know what that is, but the way I'm reading it here, bear in mind I'm a bit more international. I'm not sort of deep in the US market, but I know enough to be dangerous in the US market. But, you know, the way I understand Division 25, the systems live in there, right? And the interfaces live in there. And then what you're talking about is interface management and in IST, integrated systems testing, right?
Yep.
And that's what I liked about it. And there's an algorithmic aspect to that now. But what were your sort of insights with this then? What was your sort of 2 or 3 key takeaways when you wrote this out?
Well, so one of the parts in here, when I look at it, I wrote with Tim Howe and Jerry Pickett. One's a mechanical engineer, one's an electrical engineer, both leaders in the commissioning group here. And we always go through it. And one of the areas that, you know, is always dear to me, and with ASU, and believe it or not, John Belisle, he's the EIS manager of their energy information systems. And one day, a couple of years ago, we were working on a project. And, you know, we start to identify problems that have happened, right? And I've been so fortunate to work on a campus. I mean, that's just like the laboratory. It's the biggest resource laboratory in the world for me, right? And I love it. And one day we were sitting around and we started talking about, like, you know, point to point, you know, BAS to equipment. But there's another big one here, BAS to equipment, and then basically the back, the energy, the gathering, the trending, the gathering of information, which is one of the most important points for any building or basically university. Is basically research is platinum, right? Not gold, platinum. Okay. Yeah. And so that's why we call it the point to point to point. And it's an area with commissioning. Sometimes it gets overlooked because you're always like, oh, the BAS, I push the button and it works and I read it. Oh, I got the signal. Boom. Right. But what about when there's a large campus? What about there's a healthcare system? What about when you have like 50 buildings or an ASU, 1,000 buildings? What about when it's all connected? So a lot of times the building gets turned over because it works. Then someone's like, well, wait a minute. I'm not picking up the reading. Wait, I'm not picking up the sensors. Wait, the flow meter is not right. But you commissioned it, but at the same time, the signal works right there, right? But a lot of times, you know, what is happening with, you know, the ADX? What is happening with the SQL? What is happening with the energy management system, the retrieval system? And is the information coming in in a readable pattern? And then that's what happens when sometimes building gets turned over and then sensors don't work later, or this did this. And then you have problems and then everybody blames it on somebody instead of basically just going really thorough and say, hey, are you picking up all this information? Is it readable? So that's what we do over here now. We really focus on, it doesn't matter if it's SCADA, it doesn't matter if it's EIS system, MAC addresses, IP addresses. I mean, basically, it's all about the data, because that's why we trend. We trend, and these and smart buildings exist because of trending, because they pick up and they correct themselves, you know, and they go, oh, it's a correct PID loop. It corrects itself.
I think you need to add into your menu of courses at ASU, one on data science and one on writing algorithms, because that is the future of commissioning. Those skills need to be in your toolkit later on.
Well, you know, they call it, you know, traditional commissioning, and then basically, you know, analytical or smart building or whatever. But you still have to have statistical. You still have to sample it. You still got to go out and test it. But you can never get away from that. Whenever, you know, I'll never forget this. I had a contractor, and this is about, he said to me one time, great guy, I'm not gonna say where from, and he goes, so how do you feel about working yourself out of a job? I go, whew. I go, that's a great question. I go, so last time I looked, I go, people build buildings. I go, not machines. I go, the more that I can actually get up on basically FDDs, on algorithms, on smart buildings, I go, the more I'm going to stay employed. I go, because you keep on buildings that don't work. I go, until we live in the future, and basically, you know, we are in a machine world, which we might be going to in 100 years, but there are still, you know, ghosts in the machine, and basically humans have to find them, and you find them because you know where to look. And that's what a qualified, certified commissioning professional can do is they can really help you find where problems might occur, might exist. And all we do is basically help with solutions and recommendations to stop and mitigate risk early to save money later. And it's just like, think about it. If a building costs $100 million and I might put a $100,000 fee, what is that? Nothing. That will pay back in less than 6 months or in a week. I mean, it is the best profession in the world to be in, and it's only going to increase. And in all honesty, it's awesome, and more people should get into it.
Specifically at ASU.
Exactly. Come take the courses. One day, the goal is to have a major. That's always been my hope. And so hopefully next year, if I start my PhD, and then I'll be done in a few years. So that's my goal, is to do a PhD.
Nice.
So what's your PhD? Have you got a working title? Have you got research?
Oh yeah. Well, so I wrote a thesis basically about real-time, monitoring of buildings. But what it's really going to be doing is basically the synergy between envelope and mechanical systems. It's really about smart buildings. It's basically about how a smart building, right, and the skin and the MEP systems work together completely, so it understands. Just like a skin, it breathes, it works. So that's something that more engineers and architects need to understand about how the details and how the vapor and how the relative humidity and basically, obviously thermal, air, water, and vapor. Water is the killer of all buildings. So understand how heat, sound, great. It looks good. Appearances are awesome, but it's the physics and the science of a building that we really need to basically bring that together, and engineers and architects really, really need to talk about that and how.
You're talking Robert's language there, I can tell you that.
Yeah.
Well, the whole integrated design process, but our ethos was to start with people, and so we would teach architects and engineers, masters and PhD students about human physiology and psychology. It all starts with that, because ultimately you can build and design to every green standard you want. Pick one: well, LEED, active house, passive house, living building challenge. The list goes on and on. We had Jerry Ulyson on. I keep forgetting the numbers. How many programs did he say this?
This was a few years ago when Jerry was on. There are over 600 green building certification programs in the world.
Yeah.
That's like 599 too many.
Right. And so ultimately, nobody cares. Like, the people inside the building don't care, because all they care about is that they have 6 sensory systems. They can sense what they hear, smell, taste, feel thermally, feel vibration, odors. That's their sensory system. That's how they measure the success of an architectural engineering team.
Yep.
They don't care about the standards. Right. And even energy. And I'm a little hard on the energy folks, because people don't come with energy meters, right? They come with environmental sensors. So when we teach architects and engineers and interior designers, I don't underestimate the power of an interior designer, about human physiology and psychology, that we get way better buildings, because they understand the client.
Oh, it's just like, vision, when you actually can see, when you can feel, when you can smell, when you can hear. I mean, when you're in a place that you love to be in, you want to go there. You want to be there. You work harder, you work better. You know what I mean?
Just goes, right?
That's why we go. That's why we find our places. That's why, we have vacations, because we love the place, So imagine if we actually started really, really loving our buildings, and what energy would take care of itself if we treated those commercial buildings like we treat our house. We shut the light off. Automation is great, but it's going to shut it off. You know what I mean? Still at this day, an old school switch, just like an old school engine, you can still work on it. You can still turn it down. But when an automated switch goes off, that $1,000 switch, what do? You still got to have old school and new school, and this is just like, okay, so if my phone went out, my internet went out, what would I do? Literally, I still think that we still have to have both. It's just like basically having an electrical grid that you could have a blackout, but wait, you can have a Tesla with basically a generator that you're pulling with it just in case it goes out. You still have to have backup. You always have to have redundancy. And people, if they rely on the grid or they rely on internet of everything, we're going down a bad path. I mean, welcome to Skynet and Terminator. You know what I mean?
Something that I ask about all the time that no one has a good answer for. If we're going to electrify all cars and buildings, what happens when the power grid goes down?
You don't drive, you walk, you take your bike.
But it gets worse than that. You don't
I'm kidding, but
you don't get water treatment. You don't travel to hospital. It's a total societal breakdown over.
You still need a generator with gas, basically, or oil. You have to. I'm sorry. You know what I mean? And I always basically, with GHG, ODP, GWP, trust me, I'm a sustainability person through and through. I save energy and carbon. That's my job. I find it and save it. But what do you do when you have to have that heating and cooling, and you have to have electricals, and you have to have a UPS, and you have to have a backup system? You have to have it. I wish there was a way that we could totally rely on electrification, but
there's a philosophy. It's called design for failure, right? And I learned that a long time because I live in a climate zone, as Adam does, but our climate zone out here in the West, like it gets to -40, -50. You cannot have a failure because failures turn into huge disasters and with consequences. People can die, right? So, I was taught earlier on that when you're in an extreme climate zone, as we are, that you have to design for failure. And when I go back over my career, I'm not practicing anymore, but when I think about the career, and we would do forensics and come across mechanical and electrical systems where you look at this system and you go, you guys are effed. If this system shuts down, you're screwed. Like there is no other way of doing it, right? There's no way to bypass power. There's no way to bypass flow. There's no redundancy in fuel systems. It's done. And, and so teaching our students about designing for failure is a huge thing, but you can't do that until you understand energy conversion and how you convert or move that energy through a building and understand redundancies and bypasses and all that type of stuff. But that needs to be in the schools for sure.
In my class the other night, we went over series and parallel circuitry. I mean, I'm not teaching them engineering. I'm teaching them basics. What does series mean? What is resistant? What is a load? What does parallel mean? Basically, and then what is a short circuit? Just basic stuff. I mean, literally, what happened to the shop courses we used to have? What happened to home ec? What happened to basically, how many people even know how to sew? How many people even know how to take something apart or change your tire? Or remember the dial phone? You have to teach the past in order basically to make the future better. And we still need old school technique.
I think Jocko Willink says as well, 2 is 1 and 1 is none. You need backup and resilience, right? Otherwise you are going to get in trouble.
You just got to always think at the end in mind. Always think, like you said, to failure. Like I'm part of a lot of buildings with resiliency and redundancy. And it's just like, I always say, so when it fails, what happens? Where's the backup? Where's the default? What does it go to? What do we do? Where?
And what's mission critical? That's the other question I ask.
Mission critical.
In this building, what is mission critical? Who gets fired when what goes down? I want to know.
Exactly. Well, that's why everybody looks at mission critical as like data centers. But you know what? It's so much money. It's for profit, right? So it's just like, no stone goes unturned. But remember, not everybody has that kind of cash.
No, but my favorite example is a hospital. It's mission critical, and there's huge consequences if you screw that up. Right? Can't
go down. Can't even for a blip. Not even for a second. That UPS, nothing can go down. What do you have on e-power? What do? You have to treat it like, what if your mom or your grandma is there every day, every second of the day? Treat it like your family is there. That's what I do whenever I go through a VAV or an OR or basically a cath lab or whatever system or basically oncology. Whatever we're doing, that has to work no matter what. And that's the mentality you have to have. And that's when owners hire people that, that they're going to, I'm going to make it work. You have no choice. It has to work from day one, no matter what.
And this is where integrated design becomes really important, right? Because that's one of the things that we worked with for decades with clients in terms of, listen, when you're in these kind of, for us, again, going back to extreme climate zones, part of your redundancy or your design for failure is actually in the enclosure.
Yep.
If you've got a weak enclosure and you have a power shutdown, well, whatever's on the outside is going to be on the inside really quick, right? But if you can build a capacitance into the mass of that building, well, then all of a sudden it's not so much a problem anymore, right? So you get into hospitals, for example, if you have failures, well, your backup power system is there for critical stuff, but you have a little bit more confidence in being able to divert power if the building has the capacity to coast without the need for power, right, for some period of time. So
well, why do we buy expensive like thermal, like a Yeti? Why do we buy expensive like $30 thermals? Because you literally can put cold water in there, come back, close it up, and like in the desert, I could leave it at 100-degree car, come back 8 hours later, and I still have basically chilled water, cool water. Spend money on the envelope, spend money on the insulation. Basically, in Arizona, like just let you know, like a 110-degree, 115-degree day, if you have a completely perfectly insulated roof, walls, windows, you come home, right? Open a window, maybe something like that. You might have 85, 86 degrees. It's not going to be 115 because that's, it's ambient out there. You're in the shade. You got wind pushing through. You're in a shaded area. It is resisting the heat gain. I mean, just shade. Cover. You know what? If every building in America had a shade covering, you could reduce the load by half.
Totally. Yep.
Yes. Thank you. I'm a big fan of passive elements. Listen, we're coming up on time. I could do this forever with you, actually.
This is awesome.
Yeah, we can keep talking for hours.
But we always ask one quick question each at the end, so it's like rapid fire. So my question to you is, what's the best degree and easiest way to become a commissioning engineer? If by some miracle I'm a young kid who's 18 and thinks, you know what, I've hit my head today, I'm feeling a bit dizzy, I want to be a commissioning guy.
Okay, I'm just going to be honest. Like, you know what I mean? There's a great path to go through academics, but there's also a great path to go through trades, right? So controls technician, boiler technician, HVAC technician, folks that, you know what, a lot of engineers, they can basically design a system like it's amazing, but give them a torch, give them a gauge, they wouldn't be able to know how to fix your own HVAC. Yeah. So that's one area, right? But at the same time, listen, academics has a very good place for it. Engineers, architects, sustainability people, construction folks, you don't have to have one thing. You can basically have a passion for it and learn it. I can teach anybody technical. I can't teach passion and desire. Okay. So I know I didn't answer that completely perfect, but at the same time, come there with passion, come there with the willingness to learn, and then basically also understand how to have good human skills, because communication is probably 80% of what I do.
Agreed. So my question to you, Mark, is, and it actually leads up to, it's what you just said. So let's just say you're in front of a graduating class, and the title of your presentation is "Find Your First Tool Belt and Hang On to It." What are you going to talk to them about? That's the title of your presentation.
Okay, ready?
Yeah.
Hi, how you doing? Communication. You know what I do in my class? I make them all stand up. What's your name? Where are you from? What's your degree? Why do you take this class? What do you want to learn from it? And by the way, in my class, and my students will attest, whenever I ask them a question, like, I have to speak up. You're not talking to me, talk to them. I have them turn around and talk to each other. I have them get to know each other, because that is the best networking they'll ever have. Communication, networking, talking to each other, learning how to help each other. That is the most important part. You can teach anybody technical because you have Apollo 13 in your hand, right? Or computing power, right? But you got to teach people on how to actually not be scared to fail and be confident and talk to someone. It's communication is what is this right here, this phone, this whole like social media, and break it, right? But throw it out. You know what I mean? It's just like learn how to talk to someone at the airport. Yeah, I mean, I didn't break it. Oh well, right? But the thing is, talk to someone. Put your phone down, like at the airport, at a coffee shop. Don't be like weird, but go, how's it going? You know what I tell the students? Walk by everybody. Hi, how's it going? How you doing? Practice.
Yeah, be the first to say hello and smile. Because
Exactly. I don't have the best smile in the world. I don't have the best teeth, so I smirk a lot. But I'm like, "Hi, how's it going?" I got a big nose. You know what I mean? And it's just like, but I'm always just like, "How you doing?" It's hard to be someone. It's hard to be mean to someone when they're nice.
God, yeah,
it really is.
But you make a good point, and that is that the physical appearance of somebody is not the same as the experience that you get from that person.
Correct.
No.
You know what I mean? And then you think about some of the most inspiring people that I've met in my life are people who have had the most difficult challenges in their life. People who are quadriplegics, people that have
Stephen
MS.
Hawkins.
People,
hello.
Yeah,
guys,
right.
One of my heroes. I mean, it doesn't matter what you look like. You know what? It might as well just, it should be like, dating with no, you don't see someone.
Yeah.
I mean, that's what you should do. You should talk to someone. You should communicate with someone. It has nothing to do with the physical appearance. But I mean, it doesn't take hard. I mean, to just, hi,
no,
how are you? Or even type it. Even if in your emails, good morning. How are your day? You ever notice people just get rid of the pleasantries? I always put a smiley face in every one of my emails. Every time.
I was talking about that earlier. So, what did you say earlier, Adam? Everybody likes a smiley face, right?
So I was messaging Marcus. I thought he'd missed the link to join the call. And I said, I've sent you a message. I put a smiley face at the end so he knows I'm not angry.
Yeah. Because seriously, lost in translation, it's the worst thing in the world to basically someone takes the message the wrong way. Yeah. And then you're like, I don't like them. For what? Well, look what they read. Everybody has a bad day. You know what I mean? But it's just like...
I couldn't agree more, man. So,
totally.
Mr. Marcus, thank you for coming on. It's been a blast, and we'll do this
totally.
And at some point when travel opens up a bit more, I might come down and do a guest lecture in your class.
Oh, my God. Are you kidding me? That would be amazing. I will get everybody at ASU. I will put it on FactMan, OUA, CPMG. I mean, come on. If the building whisperer comes down...
This year, what year is it now? What year are we in? 21, right? 22, 23 latest, I'll be down. I'll do it. I've just got to find a way to work it out. I'm just taking on a new role that's going to take me away for a bit. So
yeah,
I'll work it. I'll contact you later. We'll get something done. I'll come down and confuse them with my British accent.
Yeah, it's awesome.
Anyway, thanks for coming on.
Make my day better. I really appreciate it.
And
thank you. It's great having you on.
The Edifice Complex will continue in just a moment.
Adam, it's time to thank some people who are on our side. Blue Rhythm Commissioning Software.
Blue Rhythm is the commissioning software I've been looking for. Most projects I consult on suffer from poor information and document management. Frankly, it's just chaos out there. Blue Rhythm removes this chaos. It is a secure, always available cloud solution designed to work on any computer, tablet, or smartphone. Their Android and iOS apps allow seamless transition between online and offline work. But what I like most about Blue Rhythm is their painless and fast onboarding process. Their team will bring all your existing forms and checklists into Blue Rhythm for you, or you can use or adapt their pre-built, pre-functional and functional performance test sheet templates. But it's more than that. It enables collaboration, automation, and easy planning and project management for all your projects. Blue Rhythm provides amazing support from a team that really understands your industry. To find out more, go to bluerhythm.com or call country code +1 612 460 8305. Also, you can hear from Blue Rhythm President Andy Martin on episode 26 of the Edifice Complex podcast. Robert, are we there yet? I'm bored.
Adam, I know it's hard to believe, but the future has finally arrived in Canada.
How's that then?
Well, smart remote building and equipment management is now available from SensorSuite.
Go on.
SensorSuite, yep, they're an innovator in smart building technology. We like them. They can monitor, control, and optimize anything in your building, saving you time and energy.
You mean SensorSuite are moving Canadian buildings into the 21st century?
Yeah, I know, another hard thing to believe, but they're doing it, and they're saving owners money with efficiency gains.
Okay, I'm in. How do I find out more?
Got to go to sensorsuite.com or call 1-855-773-6767. And also check out the July 2020 episode of the Edifice Complex podcast and listen to SensorSuite CEO Glenn Spry.
And now, back to the show.
Adam, that was a on fire interview. It was great to have Marcus on. I mean, how could you not get motivated by all that passion? I mean, yeah, he just sparks you up.
He's the teacher you wanted in college but never had, right?
Totally. Yeah, if you want to extract the shyness out of yourself.
He still might be in heart. Like, woo! So yeah, Marcus brings it. There's no two ways about it, right?
That's right. I used to be a meek and mild person until I had Marcus as a professor, and now I'm off the wall. And the world's following me. Yeah.
If you can take it, to be fair, some people can't, but if you can take it, he's the sort of guy you want to be mentored by when you first start, who just like straightens you out and calls you out when you're being an idiot and like shows you the right from wrong for what you're trying to do. You know, you need that. And it's like the first drill sergeant. You know, someone told me, an ex-Marine told me, when I joined the Marines, it was a horrible, boot camp was terrible, but I look back on that time as fundamental. You know, it was fundamental to build me. And yes, I didn't like the drill sergeant, but I admired the shit out of that guy. You know? Yeah. Yeah, totally. And that's really what we're talking about here. But also, you know, I really wanted to get Marcus on. I mean, I've known him for a while now through LinkedIn. But he's an important person, and this is why. Yes, he's a director of Stantec, and that's all good. And, you know, he's a king of commissioning in Stantec. That's great. But he's a teacher. Mm-hmm. And he has long-term influence. So there's a difference between short-term and long-term influence, right? He's got thousands of followers on LinkedIn, but that's short-term influence. Social media is a short-term phenomenon, right? Mm-hmm. You know, the thoughts go in a day. A teacher has long-term influence. I remember my good teachers, and I'm nearly 60, and I remember them clear as day. Right, I had a history teacher who sparked interest in history for me, and I've had that interest ever since because she was an awesome teacher. Right, nothing to do with engineering. I just love reading history because it explains everything. It explains all the stupidity you're dealing with today is in history and economics, by the way. But you know, so Marcus is important because he's a teacher. He somehow, through force of personality, convinced a proper university to run a commissioning course. Not one, two, and I'm sure he's going to grow that sucker. There's no doubt about that, right?
Oh, no doubt about it, yeah.
And he's got classes, and his classes are full, and he has long-term influence. He's going to influence people in them classes. Let's say he reaches 20 people a year, and those 20 people go out and reach another 20. You know, the network effect, the ripple effect from that in terms of influence and practice is enormous. Yeah. Society really...
That's how legends are built.
Teachers, right?
Yeah.
No. So that's my take, because I have this Confucian respect for teachers. I love them, right? But they don't get paid enough or respected enough.
No, they don't get paid enough. You know, if you think about the important people in society, those that are in the education world and those are in the health systems, no doubt about it. I mean, when people come back to this podcast and listen in a few years, we're in the middle of COVID, and we're a year or two, and here in Alberta, our provincial government was trying to reduce salaries for nurses during a time when we need them the most. It's just...
Let me get that fork and put it in my eye.
No kidding. I mean, the disconnect between what society needs and how we keep these people around. I mean, it's hard enough for them to keep them alive because of the virus, but never talk about trying to kill their souls. I mean, it's just... Anyways, totally with you, the power of teachers and we could have done several hours with him. I mean, there were some things that I loved when he talked about his first tool pouch, and you know, because it reminded me of when I was a little boy and my first Tonka toy. I don't even know do you remember?
Tonka, I remember them. Tonka toys, man.
Yeah, totally right. I mean, those stuck with me my entire life, and you know, they leave a legacy, and that's one of the things. And he went right into that from whistling while you work. His mom's advice for our listeners: it's if you're one of the blessed, you will recognize early on in your life what drives your passion. And when you find yourself whistling while you're working at what, and work could be play too, right? It doesn't have, you could be a 7-year-old or an 8-year-old. And if you're singing and laughing and whistling while you're doing that, and if that follows you through into high school and then ultimately into college and university and then out into the real world, if you are lucky to find that, consider that a gift that very few people have, you know?
Yeah.
And if you can find that whistle while you're working, the one that makes you passionate and just brings joy to your life, hold on to it and feed it and nurture it, and it will reward you, you know, one way or another. It may not be something that gives you the big bucks. And if it's something that you like to whistle while you work, well, maybe you find a job that pays the money so that you can afford to whistle while you do whatever it is your passion is. But, you know, recognize that, right?
Yeah, well, that's it. See, he, again, as a teacher, is providing a twofer. It's a 2-for-1, right? You're getting technical education, but you're also getting mentoring and life advice, for want of a better word. He's talking about the importance of communication, of being able to sell your ideas and your concepts and your work, right? These are things that universities universally suck at.
Right.
They're terrible at that stuff.
Yeah.
They're great at fundamentals. They are terrible at preparing you for the workforce. It is a joke.
Yeah, it is.
Because they restrict supply, right?
Well, yeah, and they've got a curriculum that's based on a textbook. Chances are somebody that's teaching it wrote the book.
Yeah.
But what Marcus does is he adds that fourth dimension. I mean, and that is that, you know, it's the goodwill of your heart. It's the soul, the passion that people ultimately start listening to what you have to say. You can write all the academic shit you like. I know, I've done it. I've written, as you have. We've written all kinds of papers and courses. You know, like people read it. You know, they'll read the book and whatever. But unless there's a fire and a passion that they can follow, it's waste. No, I wouldn't say wasted, but it just doesn't have the same thing. He said the thing, hands-on. Get your hands dirty. Like, again, that for those that are listening, you know, parents or students or kids, whatever, that, you know, you come to our show and you listen to this advice over and over again. Get the practical experience. Get your hands dirty. You know, your brain can deal with a lot of technical stuff and concepts and that kind of stuff, but until you put your knowledge and apply it, you're missing one of the dimensions. So he said, you know, use your hands, get dirty. He recognized learning styles. Not everybody does that.
No, that's a good teacher, right? Who can see
absolutely
you in the eye and see you're not getting it and like reframe it, right? That is gold.
Totally. Yeah. He was good that way. Yeah. Baptized by fire. We've talked about that before. Yeah. You know, like when Adam, you get onto the job sites and you've got a client that's, you know, multi-million dollars invested into a building and it's not working and they're breathing down your neck and they got to open up. You know, it's
until you've had a 250-pound pipe fitter telling you you're an idiot, a bandage with your face, you've not made it. You know what I mean?
It's just not the same. I know. I don't know if I've shared the story, but I was working for a geotechnical engineering company, and I was like this pimply faced, skinny little shit and I had to go onto a job site, and I had to, tell the concrete pour to stop because there was this guy that was watering down the concrete mix. I was told, you know, by the lab guys, if you get to the job site and they're watering down the mix, stop the pour. And I'm looking around, everybody's got a weapon. Everybody's got a rake or a shovel or something, and it's scary as hell. But you know what? You're with the engineering company. Yeah. They got to listen to you, otherwise they're done, right? Yeah. So yeah, it was amazing. I wanted to ask him if he knew Thomas from TransSolar, because when he started talking about some of his stuff, I thought, you got to know this guy. So I don't know if he does or not.
He probably does. He's very well connected. But you know, as a final thought though, what I also have sort of, as we've sort of stopped speaking to him and the energy level's gone down a bit, I also think he is a great example of leadership. Because he's taking a leadership position, right? He's leading. Yeah. I've just finished reading a book about Ernest Shackleton, his doomed or semi-doomed expedition to the Arctic. Yeah. So this is an Edwardian guy, sort of like early 20th century guy. He gets this sailing ship together, gets this group of people, goes down there, and just gets in all sorts of trouble. And they somehow, by miracle, survive. They're literally sucking water out of ropes. It's that dire, right? And it's Arctic conditions, and they haven't got them. They haven't got their, their goose feather stuff. And they get back, and the success, the ability for them to survive and get back, is basically down to his leadership. He transmitted to them all the time that they were going to make it and get through. When you walk a dog and people say, "Well, if you're upset, you transmit that to the dog." If you're leading a group of people and you're not confident, you transmit that to them. It's a wrap, right? Yeah. And, he is a great example of leadership, and he's transmitting we're going to get this done vibe. I'm going to get you through this vibe, right? Might be a bit painful, but we're going to do it, And that's leadership, right? So, there's a rare combination there of like applied engineering, fundamental engineering, teaching ability, and leadership ability. That's quite a Venn diagram that's pretty unusual.
Yeah, it is. Yeah, absolutely. He has all of the circles.
Yeah, he does. All the circles, all converging into this ball of energy.
Well, that's the thing with a lot of leaders is that they have that Venn diagram of all the characteristics, and they create a swath. Like they've got a vision. They know where they're going to be going. They've got the strategies. They got the tactics. They got all the missions they got to go on, goals. And if you're part of that, it becomes a real experience, and one you'll never forget a good leader for what they did for your soul, right? And you will never forget the bad leader for how they were so destructive.
Yeah, and they suck the life out of you and the will to live, right? A bad leader. Yeah. Anyway, he is awesome. If anyone's thinking of joining Stantec and joining his team in the commission team, I'd advise you to do it. And I'd take his course and sit there and take notes for sure. Yeah. And I hope to go down there one day and give a guest lecture. I'm going to see if I can get that going, because that would be fun.
Yeah, and shout out to ASU, Arizona State University. They have done a great. They contribute a lot, and I've been doing this now for, like 40 some odd years. And Arizona State University is one of the building blocks of our industry. If you go back and you find out what they've contributed in terms of their academics, their practical information, the way that they've inspired other leaders in the industry, they're there. And may not get, the same sort of face time as, say, a Penn State University, but they're as equally part of the existence of our industry as any other university. And as I said before, I think on this show, Dr. David Shetzley, if it wasn't for him, our website today would not be where it is.
Yeah, your website is a stealthy winner. I was speaking to IQ Radio about it. We were trying to brainstorm ways to monetize it more. I mean, it's such a resource for people.
Yeah, it's outdated and it needs a bunch of updating. I don't know if that'll ever happen. I'll probably die before that ever goes on. But yeah, David was he was instrumental, as was the students that he had working on his website at the time. They were way ahead of anybody else. I mean, in terms of what they were communicating. And so, shout out to those guys, and Marcus is in good company for sure. Yeah.
This is the purpose of the podcast, right? To showcase people who are doing good work and making a difference. So we nailed that today.
Yeah. Kudos to you, Mr. Muggleton. I don't remember where we met, whether it was in San Antonio, Texas, or probably someplace else.
Somewhere. That's St. Louis, an ASHRAE site conference, right?
Is that what it was? Was it St. Louis? Yeah. I thought it was.
I pitched you the show. I remember that in the coffee shop.
That's right. Yeah.
Anyway, it's been a good ride, man.
Yeah. All right. See you the next time.
You've been listening to the Edifice Complex podcast with Adam Muggleton and Robert Bean. To access show notes for this episode, visit edificecomplexpodcast.com. If you have enjoyed this podcast, please leave us a review on iTunes. See you next time.